Hello everybody, I'm Mahin Fatima, studying in 2nd CSM in Srinivas Ramanujan Institute of Technology. My optimization assignment topic is dominance principle. So let's go into the topic. I have this problem. We should solve it using dominance principle. Solve it optimally using dominance principle. The following table represents a payoff matrix with respect to player A. They have given one playoff matrix and we have to solve this using dominance principle. Let's solve this. First, given payoff matrix, we write this payoff matrix in the form of in all rows and columns in the form of matrix. Then the first step is check for dominance among rows. Strategies for player A. We should compare A1 and A2. As you can see in this, A1 and A2 are the rows. A1, A2 and A3 are the rows, and B1, B2, B3 and B4 are the columns. We should check for A1 and A2. As A1 is better than A2 in columns 1 and 4, but A2 is better in columns 2 and 3. So we have no dominance here. And next we compare A1 and A3. A1 we have 5, -3, 3, 4, and A3 in A3 column and in A3 row we have 4, -4, -3, 3. As here A1 is better in all columns, A3 is strictly dominated by A1, so we should eliminate A3. Next, so after eliminating A3 and A4, we have this resultant matrix, that is 5, -3, 3 and 4, -4, 5, 4 and 3. We have this 2 by 4 matrix. Next, and the second step is we should check the dominance among the columns. Now, strategies for player B. We now check if any column is dominated by another. We should compare B1 and B2. Here B1 5, -4 and B2 is -3, 5. No strict dominance. And next, compare B1 and B3. B1 here we have 5, -4 and B3 we have 3, 4. Here also the same, no strict dominance. Next, compare B1 and B4 columns. B1 we have 5, -4 and B4 4, 5. Here also the same, no strict dominance. And comparing these B2 and B3 columns, B2 we have -3, 5 and B3 3, 4. Here also the same, no strict dominance. Next, compare B2 and B4. In B2 -3, we have the elements -3, 5 and B4 4, 5. Here B2 is dominated by B4 because 4 is greater than -3 and 5 is equals to 5. So we can eliminate B2. After eliminating B2, we have this resultant matrix of B1 of having the columns B1, B3, B4 and the rows as A1 and A2. Next, third step is further reduction. Now comparing A1 and A2 again. In A1 row we have 5, 3, 3, 4 elements, and A2 we have -4, 4, 5. Here also the no strict dominance, so we don't remove it. Now comparing B1 and B3. In B1 we have 5, -4 and B3 3, 4. Here also the same, no strict dominance. So next, compare B1 and B4. In B1 5, -4 and B4 4, 5. There is no much difference, so we don't remove it, we don't delete it. No strict dominance. Since no further dominance can be applied, the optimal strategies must be determined using mixed strategy game theory methods. Thus, the optimal reduced matrix using dominance principle is, so the resultant matrix we have got After reducing, the resultant matrix is B1. We have columns B1, B3 and B4 and rows A1, A2. We have 2 rows and 3 columns. We have the elements 5, 3, 4 minus 4, 4, 5. So this is the resultant matrix. We have got reduced resultant matrix by using the dominance principle. So this is all about the problem. Next. Thank you for giving me this wonderful opportunity. I hope you found this session insightful. Have a nice day.